Hi. For my final project of augmented reality, I tried to recreate 3D objects using 2D images. As we already know that we have used Mushroom earlier in our assignments, where we used 2D images of from different angles and converted them into 3D objects. So for in my use case, for example, I used Ganesha images from different angles, and then I put it into Mushroom and created a final 3D object, which you can see in the Sketchfab as well that I've uploaded. My idea basically was that there are different softwares to do that. We know there are photogrammetry softwares like 3D Zephyr, there is re- reality capture, and there are many others. So I wanted to see how others perform on this particular aspect, how the output is, and how well it is able to recreate. I also wanted to look into something new in this domain called neural radiance field, and they have been making noise in the field of augmented reality and extended reality a lot. And I wanted to see that do they are they able to create just 3D environment, or they're able to create good 3D objects as well which are reusable. So in my thesis, or in my this project report, I start with the theoretical background, that what the background about 3D objects is. There is a small bit of history mentioned over here. What exactly is the use case of it, and what usually are used. So I talk about the older 3D scanners and what the new scanners look like. So this is a result from Leica BLK360. So there are 3D scanners which are still in use. And then I went on to talk about photogrammetry softwares, that there are softwares which can use the 2D images and perform the same thing which a 3D scanner does. Then I go on a bit about what a photogrammetry is, how exactly does it work. Here is an example of feature detection and what exactly we can do with it, and there are various kind of things that we can do with it. I go and talk about a bit about how eventually this is used to create meshes of 3D objects, and what are the different kind of software which are used. In addition, I also talk about LiDAR, that when you have LiDAR capabilities in your phone devices, how the depth measurement is used to create much more better outputs, and how this is being used and implemented in mobile application nowadays. I go on to talk about NeRFs next. So neural radiance fields are something new. How exactly they work, a bit of a general idea, like a overview. I didn't go into much detail over here, and showing an example use case of NVIDIA's instant nerf. Then I move on to implementation. So for my project, I implemented 5 different ways to build 3D objects. First was Mushroom. We already have done that. So I mentioned it a bit. 3D Zephyr is another way of creating 3D objects. This is based on photogrammetry again. NVIDIA has created something called Instant NGP, which is a nerf, which is much more faster than usual nerf. There is another implementation of another nerf designed from Nerf Studio called Nerfacto. I talk a bit about that. And then the last one is Luma AI, which has been making quite a lot of news around the industry nowadays. So I talk a bit about Mushroom. How does it work? What are the steps in between? Then I talk about the UI and stuff. Then what exactly it uses inside. Bit about 3D Zephyr, what exactly internally it uses. It's a proprietary software, so not much mention on that aspect either. But I tried to get something which they have mentioned on the paper, like they are using 2 different techniques internally. I talk a bit about it from the paper I read. I have referenced all of them, what the UI looks like. Then I go on to talk about NVIDIA Instant in NGP. They have It's an open source software, open source repository, so I was able to get much more depth understanding of it, and I've mentioned the whole thing in my steps over here. um, then similarly, Nerve Studio, I perform Nerve Studio in the labs, and currently it's being the system which I worked on is used by AR VR students, so I'm not able to get the screenshot of it, but this is how the UI looks like. And lastly, I talk about a bit about Luma AI, which is again a proprietary software, and at the back end, it's run on the website or on mobile application. Not much is available, information is available how they actually perform it. Anyway, then I go on to the results. how the original image looks like and what the final outcome is. And as you can see, Mushroom and 3D Zephyr, which are photogrammetry based output, they are quite good. In comparison to that, using NeRFs, you see the outputs are bit more hazy and not exactly that clear. But the Luma AI output was really, really impressive. And to be honest, it actually looks even quite nicer in comparison to photogrammetry softwares. Then I move on to a bit of how many triangles and vertices they create. This actually depends on how much resolution you want to give to your final 3D mesh. So this is not of much relevant actually, but the interesting part was the materials. So all these Mushroom and Zephyr and Instant NGP Nerfecto gave a 3D object output which has a mesh with one material. The way Luma AI does it is a bit different, as the output which they gave, it had 84 different materials creating the final object. What I'm talking about is, as you can see for Blender, this is the output from 3D Zephyr, and you can see in this area that if I actually get the output for the 3D model over here, this is the Zephyr output, and it just have a one textured mesh and one material output on the right, if you can see. Instead, if I try to see output from Luma AI, I can show you that if I try to see the output over here, and you can see it is created using multiple materials, as you can see over here. So all these materials together create one spatial mesh. So my basic understanding is that's my 2 cents to this thing, that they might be creating different portions of the object separately and then combining together to form one. And that's why they are able to create a very nice looking 3D object with meshes using NeRFs. So they are internally performing something which they call it proprietary and not sharing it with all the other users. But it's an interesting approach. Moving on, then I talk a bit about why NeRFs actually work and what's the benefit of using NeRFs in comparison to photogrammetry. So here is a very good idea, and this is input from one of the YouTube user who works a lot on NeRFs, and he's demonstrating that how an image with reflections compare is rendered in 3D object using photogrammetry comparison to instant NGP from NVIDIA. And similarly, so I talk a bit about why exactly does that work, and I give a brief intro about that. And there is another example of uh, actual image and video of an object with some bit of reflections created using photogrammetry versus using NeRFs. And you can see the output from NeRFs are amazing. They're exactly identical in nature. So NeRF has a really bright future. And as you can see, I tried different ways to create 3D objects using NeRFs. There are way too many new implementation. NeRF came into picture in 2021 around, and it has been in the industry for 2 or 3 years only. And there have been new implementations. Um, there are a lot of libraries which implement these, as I mentioned over here. I was not able to make use of them in the limited time I had. But in all the cases I see, what they have been doing is they have been taking the images and also providing the mesh of the mask of the object which you want to create 3D object of. Giving this as an input to a neural network is able to give you much, much better 3D outputs. So this is my basic guess that maybe Luma AI is doing something similar. Um, and right at the corner of my work, eventually noticed that NVIDIA, after Instant NGP, actually created something called NVIDIA MoMA, and which basically is what they did actually was to use Instant NGP and do something with it to create a 3D mesh out of it. So the um, NeRF original use case of NeRF was not to create 3D objects, but there are different researchers who are looking into it and trying to make use of it to create a 3D objects. So the future is really bright. I can see that. And this is an output from NVIDIA and NVIDIA's MoMA, which is using Instant NGP in the backend and able to create 3D object reconstructions. Maybe someone in the future might look into it and able to implement it much more easily. Um, I have shared all my models um, in a Google Drive. So all the models and their output are presented. It is shared in the README as well. The material and the 3D object, or maybe the Blender object, is available for all of them. I've also uploaded all these inputs in Sketchfab. So it's under a collection. And this link is also provided in the README. So this is Mushroom output, this is Instant NGP, this is NeRF, and finally 3D Zephyr. And the Luma output is, I was not able to upload the object here. The materials one were not showing up, but you can access the 3D object in the Luma website. The link is also given. Another interesting experiment that I tried to do was I used Luma, and originally I had 54 images of Ganesha, 55. What I tried to do was that since NeRF are able to detect things and objects and they don't require those many images, so I tried to create a NeRF using 24 images, 55, 24, and I even decreased it to 16 just to see if what exactly the output would be. And the interesting part is that the original nerve I've already uploaded, you can see the results. But if I see the nerves produced using only 26 images, even that is quite impressive. And it is able to capture or give similar results which we were able to receive from the original nerve using those images. So this is the final output. And it is actually as equivalently good as to the original one. As you can see, it's a take a bit time to load. So it might look bit not that clear right now, but if you when you download the object, it is much more clear and bright. Anyway, so that was really interesting. And finally, I have provided guides for each of these. If you see the final submission, I've provided guides that if someone wants to create on their own, how would you create it? So I've created for each of them. I'm showing one of these. So Mushroom is same as which we were using to create in our assignments. And for 3D Zephyr, this is the scenario. You go there, you download all those things, and I provided all the steps and everything. So if someone wants to create their own 3D objects using these different techniques, you can do that too. Maybe students next year can try one of these, and this can be one of the assignments as well. So I provided for all of these, and that's pretty much what my whole assignment is about. Project is about, sorry. Thanks a lot. Hope you liked it.